For number 5, this is graphing in standard form. So this is the one that I would cover up the 4y, and I would say my equation is 3x equals 12, and that finds our x-intercept. So if I divide by 3, 12 divided by 3 would be x is 4. And then I put a point at 4 on the x-axis. Then to find the y, I cover up the x, and that equation is 4y equals 12. If I divide by 4, 12 divided by 4 is 3. So y is 3. And then I would draw a line connecting those 2 points. In number 6, it says graph the inequality. So this is being SIF, slope-intercept form, where this is your M and this is your B. I'm going to start at 4. Then I'm going to go down 1 unit, right 2. Down 1, right 2. Down 1, right 2. I also can go up 1, left 2. This right here, less than or equal to, means that I'm going to have a solid line, and I'm shading down. So I draw my solid line. To shade down, I would start at the 4, and then down is just under. So this part of the graph is what is shaded. And we make sure that we shade the entire section under the line. Okay. For number 7, we have 2 parts to this. This is write an equation in point slope form of the line containing the points -4, 6 and -1, 3. Then transform the equation into SIF, or slope-intercept form. So first I want to label my points, x1, y1, and then x2, y2. So I see that I have the x1 and the y1 here, but I don't have the slope. So to get the slope, I have to use this formula, y2 minus y1 over x2 minus x1. So I put my minus signs in there from the formula, right here, and I plug in. So y2 is 3, y1 is 6. x2 is -1, and x1 is a -4. So this right here becomes a positive. So 3 minus 6 is -3, and -1 plus 4 is +3. This would divide and get -1. Okay, so now that you know your slope and your point x1, y1, I plug those 3 numbers into this formula. So y minus 6, the slope is -1, and then x minus a -4. So before I can go from PSF to SIF, we will make that double negative a positive. And then I will distribute. So -1x, and then -1 times +4 is -4. To get y by itself, I add 6. And I have y equals -1x, and then -4 plus 6 is a +2. Okay, now the last 3 problems right here, 8 through 10, on this page have to do with exponents, so that's unit 4. So when I see the parentheses, I know that I'm going to have to multiply that 5 to each exponent. So I have x to the 20th and y to the -15th. But I also have to change this to become a positive exponents. So I put the whole fraction over 1, and I move the negative exponent. So x to the 20th is positive. It stays where it's at, on the top. The y has a negative exponent, so I move this whole part to the bottom, and it becomes a positive. In number 9, we are subtracting our exponents with the same base. So the x's, I'm going to say 5 minus 2 is x to the 3rd. The y's, we have 9 minus 3, which is y to the 6th. And then the z's, 7/9 minus 4/9, you're just subtracting the 7 and the 4. So 7 minus 4 is 3, and we keep the denominator 9. In this particular problem, we have all positive exponents, so that's great. But we need to reduce this one. So I would say x to the third, y to the sixth, and then 3 and 9 are both divisible by 3. So if I reduce it, I would have 1/3. Then for the last one from Unit 4, we pick 3 x's. And remember, we always pick the ones in the middle, so -1, 0, 1, so that we're in the center of the graph. And then I plug them in. So -1 goes in for the x, and I have 4 times 2 to the -1. We need to move this to the bottom of the fraction to make it a positive exponent. And 2 to the first is just 2. So 4 divided by 2 is 2. So that's my first answer. Then for 0, I plug it in. So 4 times 2 to the 0. 2 to the 0 would be 1. And 4 times 1 is 4. Okay, and then lastly, I plug the 1 in. So 4 times 2 to the first. 2 to the first is 2. So 4 times 2 is 8. So now, once I have my table filled out, I can graph these. So -1 at 2, 0 at 4, and 1 at 8. And remember, when we graph it, it is a curve that gets really close to x, but never actually touches the x-axis.